Hello and welcome back to another video. In this one we'll be solving a first order linear differential equation. So let's start. So we have the general formula which states dy over dx plus or minus a function of x is multiplied by y and it's equal to a function of x. If you notice, our formula here doesn't match the general formula because we have an extra tan theta here. It doesn't match. In our case, we have dr d theta, a r plus r, which is our variable y in that case, and a function of theta, which is sine theta in that case. So what we need to do is divide by tan theta. Therefore, we get dr d theta plus r divided by tan theta is equal to sine squared theta divided by tan theta. Now to simplify it even further, so we get dr over d theta plus r divided by tan theta is equal to sine squared theta divided by sine theta divided by cosine theta. One of the sine squared cancels out with the sine, therefore we have just one sine theta left. So we get dr d theta plus r tan theta is equal to sine theta divided by, multiplied by cosine theta. Cosine theta. We could also simplify this part, as it becomes, let's just do that here, d theta plus r divided by sine theta divided by cosine theta. The cosine goes up top, now it's multiplied by r, and cosine over sine is cotan. So let's just complete this one here. Sine theta cosine theta. Therefore we get dr d theta plus cotan theta multiplied by r, and it's equal to sine theta cosine theta. Now we need to find the integration factor, and to do that it states, so we have I of x is equal to exponential integral f of x dx, or in our case it's I of theta is equal to exponential integral f of theta d theta, and that's our f of theta. So we have, if we substitute the value, we have exponential cotan theta d theta, and it's equal to exponential ln sine x, or sine theta, excuse me, and the ln cancels the exponential, so therefore we get sine theta. Now the third step is to multiply our integration factor, which is I of theta, by our formula here. Therefore we get the following. Sine theta dr d theta plus cosine theta, because because cotan is cosine theta over sine theta, and it's multiplied by sine, therefore the sine cancels out with the sine, therefore we could just get cosine theta multiplied by r, and it's equal to sine squared theta times cosine theta. Cos theta. Now the general solution will be given as the I of x times y, that's the general solution. I of x times y is equal to the integral of q of x. In our case, it's I of theta was multiplied by r, and it's equal to the integral of q of theta, and that's our q of theta. Now to substitute the values of I of x, which is sine theta multiplied by r, and it's equal to sine squared theta times cosine theta. The integral of this part. Let me just make some space here. We leave the left hand side part as it is for now, and it's equal to the integral of sine squared theta multiplied by cosine theta. When we integrate this part of the equation, we get sine cubed theta divided by 3 plus c, because sine squared theta, its derivative is cosine theta, therefore we just cancel out cosine and we increase the power of the cosine and divide by the new power. Now where we get the formula in represented by r by divided by sine theta, therefore we get sine theta, or r, equal to sine squared theta divided by 3 plus c divided by sine theta, and that's our final answer. Thank you for watching. Like if you enjoyed, and don't forget to subscribe. Thank you so much.